streaming is on.
Okay. First of all, quantum computing. Uh, this introductory lecture series wouldn't have any PowerPoint presentations or maybe any slides or like a native traditional way of teaching. I just want to be this as an office hours, like maybe we can discuss about quantum computing. We can discuss about the theories which are behind quantum mechanics and quantum computing, and we will learn together, we will discuss together, then only we can understand about the architecture of quantum computing and quantum mechanics. Most of the people, the main core issue of science communication is we are just communicating those theories to the people who really don't know what the things are doing. In my career, I was started as a science writer when I was doing my undergraduate degree. I noticed that issue. Like most of the people didn't even know how to correlate the theories which are available in physics with their real life. Most of the people, most of the students in India thinks that gravity is only supposed to be under the circumstances of Newton's law. They don't think about the moment of inertia and other components which are really present in the real life. That is the true reality of most of the flaws which we are facing in the science communication. I hope some people are came from various countries, which I have mentioned as a global lecture series. Since even though I am a student, I am very much happy that six people have attended this program. Let me start this as a discussion. You can ask any kind of questions you have. First thing, let me clarify. This lecture series would take around few weeks, maybe it would stretch up to 3 months to complete the basic ideology of quantum mechanics. First of all, we should have to really understand what is quantum mechanics. We have to be precise about how does the qubit, how we are using an atom or maybe a photon or maybe an electron or maybe something which we can't see even using a microscope, how we are interacting with those things and how we are doing those calculations, and what are the constraints, what are the things which we have to keep it in our minds, how we can simulate those qubits in our real environment, what is qubits, and what are the difference between the classical theory and the quantum theory, and how we can reduce the errors, what is quantum errors and what is how we can reduce those errors. This series will it is like a open source community discussion. So um, let me share a link in this end of this session, and also I will share those links in this particular YouTube live also. You can join our Discord channel and you can ask any doubts which you face in terms of quantum mechanics. Let me clarify. Can anyone, I think only 6 people are there, most of them from India, I think so. Can everyone introduce about themselves? Maybe. Uh, can everyone start? I think Eva is from Open Science Labs. Sir, can you start? Give a small introduction about yourself. Or maybe like I just want to know in which disciplines people have came from, so I can easily and I will give examples which related to them, because that is the main thing which we are dealing with quantum mechanics also. uh, can anybody give their introduction for first?
Yeah, I'm Satish Kumar. I'm audible.
Yes, you're audible.
I'm Satish Kumar. I'm professor in Sri Sai Ram Engineering College.
It is nice to meet you. You're from physics or any other discipline?
Couldn't get you.
You are a professor in which discipline or which
Physics.
subject?
Physics.
I think, sir, there is some noise, background noise from your side. I couldn't hear you. Okay, nothing to bother. Maybe.
Okay. I'm going next. I'm Srini. I'm a IT engineer into cloud operations. Just interested to know about what's going on with quantum.
Okay, nice to have introduction. What about Dr. Karthikeyan, sir? Can you give your introduction? I think he is offline right now. Okay, I think let me check. Maybe. Okay, okay, okay. Sir, you can put your brief in the message also in the chat box also. That wouldn't be a problem. You can put there also. Okay. Okay. And okay, and Jane just starting. Okay, no issues, no issues. Okay, I think it is already 15 minutes. Let me start. And first of all, most of the people have learned about. I'm Karthikeyan, assistant professor of physics. Okay, sir, nice to meet you. I hope I can learn way more quantum mechanics from you yourself also. And first of all, quantum computing is a new. Most of the people think that it is a new discipline of computational analysis. First of all, we already know the history about computers. Initial days, we have addition and multiplication, subtraction, and some basic fundamental mathematical equations. After thousands of years of innovations, theories, and great philosophers' works, we figure it out differentiation, integral calculus, with the help of Newton and some other scientists of the after the 50th centuries. We need a machine because we can't do all those calculations entirely by just by using our hands or with just using our using those notebooks and etc. So people needed a machine or maybe a mechanical tool or maybe something which can easily outperform those complex mathematical equations, complex polynomials, differential equations, series of numbers, or maybe something like that. Then only the search of computers, the search of calculators was started. We already know Charles Babbage was the main person who is behind the innovation of computers, or maybe many people have developed for those things. The classical computers are which devices which we are currently using right now, maybe like my mobile phone or this laptop or any other electronic device which you are currently using right now, are made up of electronics or the integrated circuits. Maybe in technical terms, we will call it as classical bits, or maybe like we are just using transistors. Let me clarify one thing. Let me imagine about a switch. Maybe there is two probabilities. You can turn on the switch or maybe turn off the switch. Like the you can turn on the LED bulb, you can turn off. There is only two options. There is only two. If I turn on the switch, that is one. If I turn off, there There no current will be flow through the circuit. There will be zero. We already know that. That is the thing behind those classical computers. Even though most of the people have came from cloud computing, programming, and some other disciplines, most of the people think that most of the people uses Python, Java, and some other programming languages or maybe assembly language to communicate with their hardware. Basically, we are using an Intel processor or maybe a Ryzen or some other processor, RAM. All of the things which we are currently using are just able to communicate using zeros and ones. That is called as the binary language. Or maybe this zeros and ones are so precise that currently the mobile phone I am holding in my hands have around 2 billion transistors inside of it. It has somewhat some this size of maybe a 2 centimeter chip inside of this, maybe made by Snapdragon or some other company. But it contains around 200 billion transistors. Could you imagine? 200 billion transistors. I think 20 times more than the human population. The 20 times more than the number of the human population. The 200 billion transistors just infused inside the core chip of my mobile phone. How does it possible? That is about thanks to electronics, digital electronics, which made us possible, which made us possible to do calculations, computations. And I already told you there is only two options. It may be one or zero. You may, let me give you an example. You may notice this thing initially. When you're using your mobile phone, can anybody in this group, can you share how much RAM which you have in your mobile phone? Just for discussion. Can anybody share? Can anyone, maybe in the chat or just turn on your mic and share? Just how much RAM and storage which your mobile phone currently having? Can anybody share? Okay, thank you, Vijay. 8 GB of RAM. Maybe his mobile phone having 128 GB of storage or maybe 256 GB of storage. We call it as random access memory. 8 GB. Thank you, Sadish Kumar. Maybe 8 GB. My mobile phone also having 8 GB. Okay, okay. Uh, Now I'm audible. Okay, let me start once again. Um, okay, okay. My mobile phone also have 8 GB of RAM. Uh, Most of the people, when we split those words, it has 8 gigabytes of RAM. 8 gigabytes means 8, 10 to the power of 6, 8 into 10 to the power of 6. Maybe in terms of words, I think it would stretch around 100 million. I think so. Giga means maybe there may be some errors. 8 into 10 to the power of 6 bytes of random access memory, which I have currently right now in my hands. This is the computational power of this device. Here is the crazy part. What we are really using in this mobile phone, even though I have also faced this, if I installed a program which goes up to 1 GB, it couldn't sustain. Why? Because in terms of transistors, it just blocks to, it has only two options. It sometimes it blocks the voltage or sometimes it releases maybe 10 10 10 like that. Most of the people, in other words, the screen, the thing which you're seeing on your screen right now, maybe my image, it is just consists of zeros and ones. If somebody which he able to recreate the zeros and ones without having the link to my live, without having, without even knowing my face, he can recreate this environment entirely. We are living in a world currently, we, we are living in a world which is made up of classical bits or classical bits technology. But what is qubits? Here lies the real question. Here lies the real innovation of future. We already discussed that we have. Okay, I think he had a doubt. Yes, sir, you can ask.
What is the limitation with the current electronic-based calculation, Kaliswaran?
Current electronic based calculations, the limitations are mostly fed by the uh, programmers itself, I think so. This mobile phone uh, could be able to solve different kind of calculations, maybe NASA level calculations, but it would take around hundreds of years to solve those equations. The battery backup wouldn't even sustain for a single day. The processor couldn't even handle those performance. So the embedded programmers would purposefully stop those computations, like in a normal 8 GB 8 gigabyte mobile phone, you can't install a application which can hold up to 500 GB or 1000 GB. There is a physical limitation which is fed by the embedded programmers. But basically, these devices are meant for classical manual calculations. These calculations are deterministic. Let me imagine a person, like I go to a classroom, maybe a preschool. I just ask one student to count from 1 to 100. He starts to count 1, 2, 3, 4, 5, and it counts linearly. It is just a linear line. He starts from 1 and ends at 100. Maybe he took 1 minute to complete those tasks. That is the thing. Our classical device, this mobile phone or your laptop or some other devices which we are using currently, using this kind of technology. When you're fetching a program, it takes some runtime. It checks all those values, all those possibilities, and do the computation. Basically, it is enough for the current era of human usage, but these machines are not sustainable for handling higher level mathematical equations. Um, Most of the people know about that. The current scenario of most of the people learned about that when quantum computers came to power, current configurations, current security patches for banking softwares will be easily cracked down by a normal quantum computer. The reason is, let me jump back to our example. Like a boy is counting from 1 to 100 one by one. But what about qubits? The same time, I asked 10 boys to count from 1 to 100. But I assigned the first boy to count from 1 to 10, another boy to 11 to 20, and it goes on. So they can easily count. They can, initially the boy took 1 minute. These boys can easily complete this task within 10 seconds. That is the thing actually quantum qubits are doing. Qubits are basically maybe ions, electrons, photons, or maybe some other particles or some other waves which are trapped inside a, quantum chip. I think Google has developed Manjaro, IBM has developed some other chips, and some other China and some other world countries are developing quantum chips, which are basically works on this principle. Uh, well, in terms of quantum computing, initially I have started this lecture uh, In this lecture, we will going to see about quantum mechanics, the theories lies behind quantum computing, the things behind quantum computers, quantum error reduction, and the future of quantum computers. This lecture series will be continued for every Saturday at 10:15 p.m. IST. In this introductory section, I have given an introduction about the quantum computers, I hope. And on the next sessions itself, we will discuss about the classical theory and the birth of quantum mechanics. After a few sessions, we will directly dive into quantum computing and we will do some hands-on activities in terms of QIS kit using QIS kit, which is a quantum-based library, quantum-based open source library. And we will also do some electronics projects which we can able to mimic or simulate qubits in the real world. And in the upcoming sessions, we will going to discuss about it. And uh, these sessions will be a shorter sessions. Maybe I will teach for around 10 to 20 minutes. And afterwards, we can do some discussions. We can discuss those things on our Discord channel. Let me share my Discord link here. Wait for a few minutes. Okay. Okay. I think if you have any doubts or if you have any suggestions about the session, you can share right now. I think three people are there, and that wouldn't be a problem. Even though if nobody is there, I will do my job as I will take my lectures. I hope you have any suggestions or doubts, you can ask right now. Once again, let me share those links here. Also, with the help of Open Science Labs, from this week itself, I will release the materials for learning about quantum computing. Uh, Looking animation for easy to understand. Okay, from the next lecture series itself, I will use some animations, but I feel that using PowerPoint presentations often uh, I feel like I just want to break the classical way of teaching. So then only I used an interactive session for the initial day. From the next classes itself, I will use some animations to explain about the quantum computing. I hope there is a ton of open source content which we can observe about quantum computing, and also we will going to simulate about the qubits itself. And so let me share this once again. Okay, brother. I hope it's late in Sri Lanka. Okay, we will meet tomorrow. Okay. I think there is some issue in my Discord server. I will share the Discord link on the Open Science Labs blogs page. Once again, I will share the link. Open Science Labs. Okay. Okay. It is not even updated right now, but I will share the Discord link and the very first article about the introduction to quantum computing on Open Science Labs slash Open Science Lab org/blog. I will share those blog posts there. And from the next week itself, we will going to discuss about the theories of quantum mechanics. We will going to solve those numerical equations, Schrodinger's wave equation, and don't be fear about the think of quantum mechanics. It will be so easy, so interactive, and it would be so fascinating. We are ready to learn about the future. And thanks for joining, everybody. Thanks for joining in this introductory lecture. And I will also share the reading materials and books which are available in open source on this particular Discord link. Also, you can contact me on Open Science Labs forums and on my Discord chat. And I really appreciate the group discussions where we can learn together and build the era of quantum computing for the future. It's already too late. Share your comments if you are watching this live session on YouTube or maybe the recorded session. Share your comments and feedbacks. We will meet in the another session. Thank you for joining. Thank you, everyone.
Thank you, Kali sir.